Hola, you're welcome. Today I will push my limits and show you a circuit I've designed. A couple of components I've not actually used before, so it's kind of new to me. I'm definitely pushing my limits. It's basically an add-on to my amplifier, which is here. And it's an automated cooling system. I'm going to operate this thing at 19 volts when I switch it to mains, using an adapter, of course. And I've noticed when I test it at 20 volts that these output transistors get quite hot. I'm sure they can dissipate the heat, but they get quite hot. And the casing is made of wood, of course. So I'm not going to risk, a fire. Just in case. So I'm going to put I was thinking of putting a cooling system that starts, a fan that starts at a certain voltage when it reaches a certain voltage. And I looked it up. I don't know how to do it, so I looked it up, and it seemed more complicated than, I kind of expected. So I decided to design this one instead. If you want to view my amplifier project, it is over here. And basically, I don't want the cooling to be constantly on, because what will happen is when it's on battery powered, it will then drain the battery, something extra to drain the battery. So I want the batteries to last as long as they can. So I have designed instead in fact, I'm not going to tell you now. Let's go. I'll show you. So today I work with this little fella, a thermistor. This is a thermal resistor, hence a thermistor. Basically, it changes the resistance depending on the heat applied to it. So if things get hot, the resistance changes. These particular ones are NTC thermistors, which are basically, what it means is the resistance goes down as the heat goes up. As far as I know, that is. I've just recently learned about these. So let's measure this thing. So we have this little fellow here. He's happily all nice and cool. And he is 5K. I have one here that's actually 20K. So this is a 5K one over here. And when I pinch him, and obviously with the heat from my fingertips, he's going to get warm. And of course the same thing if you have a 20K thermistor, a 20K NTC thermistor. Test him, he is 20K, it's 20K, it's showing 21K. Must be very cold. So I put him between my fingers and he warms up, and then the resistance goes down. It's jumped down to 14K, 15K. And it's obviously going lower now. Now, this guy will come in handy for controlling this, which is, a cooling fan. I want this in my amplifier, obviously not this one. This one's huge. This one's just for testing purposes, a spare one I have lying around. But I'm going to have a smaller one. The components I'm going to use for this, when designing this, is this variable resistor. Obviously the real one will be, small PCB one, just to adjust. And this is a MOSFET, an IRF 540, and the N-channel MOSFETs. Okay, now we go to my little whiteboard, which is basically my doodle pad, my scrapbook. I jot down ideas, I work things out, because I work visually. And I'm bad at mathematics, but I'm good when it comes to visual stuff. So, we have the plus volts, the plus volt rail here, which must make it plus 10 volts. Ground, which is here, which is 0 volts. Let's just put that in there. This is basically a voltage divider circuit. If you have, let's say for example, 10 ohms, two equal resistors here, it will have this voltage, so you will get 5 volts out of here. Now similarly, if this was not 10 volts, if this was 20 volts, you'll get 10 volts coming out of here. So whatever that is, it'll just half it. Alright, so we have, and it doesn't matter if this is 10 ohms or 10 kilo ohms, as long as they're both 10 kilo ohms, you will get 5 volts out of here. It'll just half it. However, if you were to have, you know, something like 8 ohms here and 2 ohms here, I'm not going to write any values down because I'm bad at mathematics. This works with ratios and I'm bad at math, so I'm not going to write any values, but I'll just tell you what happens. There is less resistance to ground and more resistance to plus volts, so you will get it lower than half. So in this case, lower than 5 volts. However, if it's the other way around, you have 8 ohms here, 2 ohms there, it's going to be higher. It's going to be higher than half. In this case, higher than 5 volts. Because there is less resistance, you know, between the center and plus volts, and more resistance between center and ground. So you will get, you know. So the circuit which I'm designing will be based on a voltage divider, naturally. You know, so what I'm going to do here is this happy fellow here, this variable resistor, I will put him here. There he is. Here's our little friend, and the center point, and you have the junction here and the center part, and then the top of it, who will be here, he will be our little friend here, which is a thermistor. So it's like a resistor with a hockey stick on it. That's a symbol for a thermistor. And the heart of the circuit, this dude here, is this MOSFET. He will be here. So you have this, and that, and go down here. This goes down. This guy connects to ground, and this guy goes up here. Okay. This is basically, this is 20K. This thermistor is also 20K. So you get the voltage divider thing going on. And this is gate, drain, and source, which is on this will be, you have so the pin out of this guy is a bit of a long one, but the pin out of this guy is gate, drain, and source. How I remember this is goodest. So yeah, that's how I remember this dude. So we have these here, and of course over here is gonna be our fan, our friend here. So let's put him there. Oops. I was skidding around. There you go, there he is. Well, this is not the official symbol for a motor. The official symbol for a motor is actually, you know, that with an M. But come on, this is me. I don't want to be boring. Actually, it could be M for Maddie. Cool. Anyway, moving on. Before I get any ideas. Right, so we have this. What's happening here is that I think the gate here requires 5 volts. to kind of switch on, and when this switches on, the current goes through here, comes out of here, and you know, goes down the source. So this, it completes this circuit. I think, I'm not sure, but I think if you have a normal motor here, you will need a diode. Let's make a junction here. You will need a diode here. However, the reason why I'm not putting it in, because these cooling fans have already got diodes built in. So we have the diode here already built into the fan. What I tend to do is, any circuit like this I just put a capacitor here, an electrolytic capacitor. In this case, it's going to be something like 100 oof. Basically, it's 100 microfarad. Of course, you know, I'll put a good voltage. If it's 10 volts, I'll put 16 volts just to keep it safe. So yeah, that's basically it. That's basically what I'm going to be building, or what I'm going to be testing now, I should say, because I have my breadboard kit, and I will do it here. Basically, what happens here, you can adjust the bottom here, the limit of that, and this, you know, obviously this is goes up and down depending on the temperature. So this voltage will go up and down. If it's below 5 volts, this will not be on. This fan will not be on. If it's above 5 volts, this will of course be on. So yeah, so you can just like mess around with the voltage divider part of it here and adjust the sensitivity of the sensor. Right, so here we have, you know, the breadboard here, and the breadboard connects with vertical lines, except for this middle bit. It connects, these 5 holes connect with vertical lines here, like that. Right, so over here we have our thermal resistor, which is connecting straight to plus volts. So we have that here like this. Then we connect one of the sides, one of the pins, to the plus volts rail up here. So we have that. And the other side of it goes to this middle thing, which is basically the gate of the MOSFET. So the gate of the MOSFET is over here. And the gate of the MOSFET is this first pin here, GDS. Oh no, sorry, connected to the second one there. Okay, first one, okay, here. The second one, sorry, and I'm going to continue all the way down here, which is the variable resistor, which is this thing. Okay, how I'm going to do this. The 0 volts here. The 0 volts here, I'm going to use a crocodile clip to one of these sides here. It's just any of these. This is a dual gang one. So, and the other side of the variable resistor connects to the gate. The gate is here. So there's another one going to gate, so you just put it underneath it. So you have the gate of the MOSFET going here, and the other side of the cable connects to here. It's like that, and of course you short the top 2 out. So let's just connect it like this. So it's shorting them out like that. So we have that part of the circuit, this part of the circuit sorted, and some of that sorted out. Let's connect the source here from the thingy, which goes all the way to ground. The source is GDS. So the source goes from here and connects to ground. Now what happens is you have the drain and let's get this thing. Okay, we connect the negative of the fan into the drain of the MOSFET. So GDS. So GDS, which is the pinout, you have the center one is the drain. So GDS, so it's the center one. So you connect that to the drain, this green one going to the negative of the fan, and obviously the top bit, the positive going to positive. And that's it. We've done it. That's how simple it is. So this is plus volts. I'll just like tap it off there and put it here. Right, okay. Let's just like save time. Instead of getting the power pack up, let's just do it with a 9-volt battery. So the plus volts, which is this, connect that, oops. Yeah, this is, connect that to here. And we have the negative, which is right, so we connected that, the fan is obviously going. And let's turn the variable resistor to adjust. Okay, variable resistor adjusted, so that's switched off. Because, why is it switched off? Because there is more of a connection to ground, so that has gone lower than 5 volts. So there's more resistance across this thermistor here. Now, how do we lower the resistance of the thermistor? Well, it's an NTC thermistor, so we heat it up. Now, if I put my fingertips on that, we'll heat this guy up, and there we go. The resistance there lowers, so there's less resistance to plus volts, so that gate voltage climbs up to 5 volts. Now if I let this go, naturally that's actually cooling that down. The resistance increases, so there is less resistance here and more resistance there. This little dude here is a thermistor, and you heat him up. You heat him up. The resistance goes low, less resistance between the gate and plus volts, therefore increasing the voltage, and the gate switches on. You let it go, it cools down. And that whistling and tweeting which you can hear is the sound of the MOSFET. Just kind of like, oh, should I switch on, should I not? It's kind of the gate of the MOSFET kind of turning itself down. Sounds like there's a bird in my circuit with all this twittering and chirping. But hey, pretty cool. I'm all excited now. And what you can do, the beauty of it is you can adjust the sensitivity. Basically, if you were to actually decrease the resistance here in the between the gate and the ground, you would therefore change the ratio of this, which means that you need to heat this up even more so the resistance goes even lower. So obviously it won't just switch on at any old, body temperature heat. If a transistor heatsink gets very hot and heats this up, then it'll switch on. Otherwise it'll just switch on, it'll be more sensitive. So you can make this more sensitive and less sensitive. So yay! I'm so happy this works. Now next stage is to actually build it and put it into my amplifier. Oh, little bird has adjusted itself.